Hi, this is Karthik Rajkumar, and today I'll be presenting to you the hallmark of cancer prevention, the hypoxia-inducing factor. So to say a little bit more about myself, I'm coming from Merida, Georgia, where I'm a rising senior and a STEM biomedical student at George Walton High School. I've been playing the alto saxophone for many, many years, making the all-state band 4 times and the honor band 5 times. I'm also a very avid guitarist who's been playing for over 10 years and has performed in a variety of concerts. I'm the president of both the Chess Club and the Walton Tutoring Club. And I'm also a member of various honor societies, including the National Honor Society, the National Honor Science Society, and the National Honors Math Society. Earlier in the summer, I had the opportunity to shadow a nephrologist in this clinic for 40 hours, which truly inspired me a lot to learn more about HIF, particularly after spending a week learning about the kidneys a lot. I had the opportunity to be inspired by working with an MD doctor who taught me a lot, and that allowed me to want me to research more about HIF. I also had the opportunity to attend the 2024 Georgia Tech crystallography workshop, which taught me a series of biomolecular techniques by doing many experiments that enable me to learn more about HIF and also be able to comprehend at the molecular level what's happening. So in the future, I hope to graduate pre-medicine, graduate medicine, specialize in neurology, and eventually open my own clinic. So why is cancer such a global concern? Well, that is because in the United States, by the end of 2024, there will be an estimated 2,001,140 new cancer cases and 611,700 new cancer deaths. And that is incredible because cancer is definitely known to be a deadly disease, but people often tend to underestimate how many people are losing their lives in a given year because of this cruel disease. And based on the rate at the bottom, in every minute, by the end of every minute, 4 new cases appear and 1 person dies. By the end of this presentation, we will see a total of 32 new people diagnosed with cancer and 4 of people, also other people, who would have died. So these statistics right here are sex independent, indicating that breast cancer is the top incidence, has the top incidence among both sexes, and the top killer is lung cancer. So what is the hypoxia-inducing factor? Well, to start off, hypoxia refers to any oxygen-deprived condition in the human body, and HIF particularly functions in the kidney. Now, HIF's primary job is to maintain oxygen homeostasis, but as we can see, there are several other subunits based on the central image here that allow for other functions. And the first and third images represent the external subunit and the external structure, which primarily consists of alpha helices at the secondary structure of the protein. So our main focus will be on the proteasomal degradation unit, which consists of ODD, which is the oxygen deprivation domain, which allows for HIF to either be turned on or degraded, depending on oxygen concentration levels. So what is the primary mechanism of HIF? Well, primarily responds to renal anemic conditions. So in a normoxic condition with a normal O2 concentration, which I've indicated using 2 circles because oxygen is the diatomic element, the ideal relationship with HIF in the kidney is severed as a result of there being no need for HIF, which does not affect erythropoiesis, which is the production of RBCs. So in turn, red blood cells are not affected. And that makes sense because oxygen concentrations have not changed. However, in a hypoxic environment, when we reduce the oxygen concentration, in this case by 2/3 or 66%, HIF must remain on in order to allow for increased erythropoiesis, increased red blood cell production, which increases hemoglobin concentrations, eventually allowing for the restoration of oxygen carrying capacity back to homeostasis. So how does HIF relate to cancer? Well, HIF promotes anaerobic respiration. And important to note is that cancer cells most often are found in hypoxic environments. The reason this is important is because they are usually exhausted because they've used up all the oxygen in their environment. So they have to resort and find an anaerobic way to sustain themselves and ultimately grow into a tumor. So ideally inside the respiration, there is one anaerobic process called glycolysis and 2 aerobic processes, pyruvate oxidation and the citric acid cycle respectively. And ideally, in the middle process, a complex forms called the pyruvate dehydrogenase complex, which is affected by HIF because the HIF tends to activate this other enzyme called PD kinase, which takes a floating phosphate group and phosphorylates effectively the pyruvate dehydrogenase complex, rendering this complex inactive and also rendering the pyruvate oxidation and the citric acid cycle inactive. And the reason this is important is because the cancer cell has successfully forced itself into an anaerobic process called glycolysis, and with the help of fermentation, will continuously regenerate NAD+ and continuously yield the output of ATP found here. And this allows for sustained ATP production, all possible only because of HIF. And HIF allows for this mechanism for the cancer cell to force itself into anaerobic respiration. And the mechanism I'm going to talk about is to alleviate HIF, which will prevent this mechanism and force the cancer cell back into aerobic respiration. And you guessed it, without oxygen, the cancer cell will die. So how do we know that HIF really affects hypoxic environments and is a result of hypoxic environments? Well, the data that proves this is statistically significant. So as indicated here, the gray bars represent hypoxic environments and the black bars represent normoxic environments. So the first thing to notice is that in all these bars across all three graphs, the standard error bars do not overlap, indicating that every piece of data comparison here is statistically significant and not a result of some other external factor. So the first graph, glycolytic rate, shows that glycolysis is increased under hypoxic conditions, showing that any cell will naturally shift to an anaerobic process like glycolysis when there's a lack of oxygen. Lactic fermentation, lactic secretion as a result of lactic acid fermentation, which is anaerobic, has also increased under hypoxic environments, showing that in hypoxic environments, the cell resorts to more fermentation, which again is anaerobic. Now, why is lipid synthesis actually decreased in hypoxic environments? Well, that's because cancer cells oftentimes want to preserve their energy and decrease their metabolic pathways appropriately. So what is the novel mechanism I'm proposing? Well, using this enzyme I mentioned earlier called PHD2 or proline hydroxylase 2, we can monitor the relationship with HIF by checking out the subunits, the alpha and beta domains. And by looking closely at the alpha domain, we can see that there is the oxygen deprivation domain, which using the help of BBAP1 and BBAP2, two respective activators, we can activate PHD2. And upon activation, PHD2 will successfully hydroxylate the oxygen deprivation domain. And upon hydroxylating the oxygen deprivation domain, the entire HIF alpha domain has now been rendered ineffective, and HIF has ultimately been degraded. And with this, and decreasing the concentration of HIF out in the human body, we can force the cancer cell back into aerobic respiration and ultimately kill the cancer cell. So potential limitations, of course, the patient cannot be anemic. The patient must have stable oxygen carrying capacity. And using tests like hemoglobin A1C can help confirm whether this method is liable for this specific patient. So the major takeaways in conclusion include that HIF can serve as a significant biomarker. HIF regulates oxygen homeostasis by interacting with the kidney and bone marrow. HIF promotes anaerobic metabolism, which we are trying to reverse with BBAP1 and BBAP2. And the key point to take away is that forcing the cancer cell back into aerobic respiration in an oxygen-deprived environment is key in treating cancer. And of course, all this is done by degrading HIF using BBAP1 and BBAP2, which activate PHD2 and degrade HIF. And of course, all of this is an area of upcoming research. Here are my references. Thank you to everyone who's helped me in this journey. And here are my contacts. Thank you.